Welcome to Section 4 of the Acid-Base Physiology Review. In Section 4 we will walk through acid-base disorders. We will also provide a practical, systematic approach to acid-base disorders both on the USMLE STEP exam as well as in your clinical scenarios. Welcome to Section 4 of the Acid-Base Physiology Review. In Section 4 we will walk through clinical scenarios of acid-base disorders and provide a basic framework for approaching acid-base disorders in the clinical setting. Some starting tools you need to know. Before trying to interpret an acid-base disorder, the two things you will definitely need are 1. Arterial blood gas, and 2. A serum electrolyte panel. We will discuss in more detail how we use each of these. Acid-base problems can be a difficult part of the USMLE Step 1. The important thing is to remember to approach this in a systematic fashion. If you approach each problem in a systematic fashion, you are less likely to make a mistake that you would otherwise not make. Here we have outlined 5 easy steps to approaching an acid-base problem. The first is to determine the pH. This tells you whether there is a setting of acidemia or alkalemia. Then you determine whether the primary process is respiratory or metabolic, or both. Next, calculate the serum anion gap. Number 4, check the degree of compensation. And number 5, in the setting of a metabolic acidosis, determine whether there is a 1-to-1 relationship between anions in the blood. This is also known as calculating the delta gap. A few normal values for acid-base problems. On the USMLE Step 1 exam, these values should be given to you, but for the purposes of these problems, you should keep these in mind. Once again, the normal pH ranges between 7.37 and 7.43. Normal PCO2 can be approximated at 40 millimeters of mercury, but it ranges from 36 to 44 millimeters of mercury. The normal concentration of the cations of blood, sodium is 140, potassium is 4, normal concentration of anions, bicarbonate, is between 22 and 26 milliequivalents per liter. We use 25 milliequivalents per liter. Chloride is approximately 100 milliequivalents per liter. The normal anion gap is between 8 and 12. Step 1. Determine the pH. Is the patient acidemic or alkalemic? If the pH is low, there's an acidemia. If the pH is high, there's an alkalemia. Relatively straightforward. Step 2. Determine whether the primary process is respiratory or metabolic, or both. Once again, acidemia occurs in the setting of both metabolic acidosis and respiratory acidosis. Metabolic acidosis is the primary cause of acidemia if, in the setting of a low pH, the bicarb level is below the normal range, or less than 25 milliequivalents per liter. However, in the setting of acidemia that causes a respiratory acidosis if the PCO2 is greater than the upper limit of normal, or 40 millimeters of mercury. And alkalemia is caused by a metabolic alkalosis if the bicarbonate concentration is above the normal range. And a respiratory alkalosis is the cause of alkalemia if the PCO2 is below the normal range. We use these parameters and these definitions to determine what the primary etiology of an acid-base disturbance is. Once again, let's take each pathway. First, the pH is low, and you diagnose acidemia. Then look at the serum bicarbonate concentration. If the serum bicarbonate concentration is low, you have your answer. There is a metabolic acidosis. However, if the bicarbonate concentration is normal or even high, look at the PCO2. If the PCO2 is high or above the normal range, you have a respiratory acidosis. Let's look at the other side. If the pH is high, you can say you have alkalemia. First, look at the serum bicarbonate concentration. If the bicarbonate concentration is high, then a metabolic alkalosis is the cause of the alkalemia. However, If the serum bicarbonate concentration is normal or even low, look at the PCO2. If the PCO2 is low, you will see that the respiratory alkalosis is the cause of the alkalemia. We'll go through that chart a few times, giving yourself different scenarios. If you approach this in a systematic fashion, you will always identify the underlying disorder. Step 3. Calculate the serum anion gap. Do this always, even if you have not yet diagnosed a metabolic acidosis. This is something that can be easily missed and will lead to unnecessary errors both in the Step 1 exam as well as in clinical practice. What is the anion gap? Remember that the cations in the solution always balance anions. The human body blood is not charged. However, many plasma cations as well as anions are not routinely measured. The primary measured cations and anions are sodium, chloride, and bicarbonate. The balance of cations and anions